Today we are going to graph radical equations. So we're looking at two. Primarily we are looking at the square root function and the cube root parent function. The square root function is going to always look like a curve, right, like this. So our parent function, it's going to have a vertex, it's going to be at 0. And the main reason is because the square root function is an x underneath the radical. Well, we know that it has to be positive. So your vertex starts at 0, 0, and then I'm just going to pick some easy numbers to take the square root of. 1, 2, and 3. I could have picked anything, but I didn't want any decimals. So my values would be 0, 0, 1, 1, 4, 2, and 9, 3. And then I get this curve like this. Okay, so your domain for this one, it starts at 0 and it goes to positive infinity. The range starts at 0, goes to positive infinity. It's increasing from 0 to positive infinity, decreasing nowhere. It's positive from 0 to positive infinity. It's negative nowhere. I do not have an extrema because, well, I have a minimum is at 0. Your max extrema, there is none. Symmetry, it is symmetrical to the, well, our x's would be negative, the y would stay the same, so that means that it would be symmetrical to the y-axis. In behavior, as x approaches positive infinity, your y approaches positive infinity. As x approaches 0, your y approaches 0. That is your square root function. The other parent function that we're going to look at is the cube root function. My thing is not pinching. Okay, so we have a cube root function. The equation looks like this. It's going to look like a snake. So it's going to go through 0, 0. I'm going to pick perfect cube number on the left, perfect cube number on the right, and then I'm going to pick negative 8 and 8 because I can take the cube root of negative 1. I can take the cube root of negative 8, cube root of 1, cube root of 8. So that means it's going to be here, 1, 1, and 2, 8. Negative 1, negative 1, negative 2, negative 8. So my graph is going to look like a snake going up and down. Your domain, negative infinity to positive. Range, negative infinity to positive. It's increasing from negative infinity to positive infinity. It is not decreasing. It's positive from 0 to positive infinity. It's negative from negative infinity to 0. There is no extrema because it goes to infinity. And this one is going to be symmetrical to the origin. Okay? In behavior, as x approaches positive infinity, y approaches positive infinity. And as x approaches negative infinity, y approaches negative infinity. Oops, this is negative. Okay, that's the two radical functions that we're looking at, square root and cube root. This transformation chart, I hope you recognize it. It's the same one that we've been doing. If you have an h on the inside, that means it's going to shift right. The equation for square root would look like this. This would be left h. The equation would look like this. If your b value inside with the x is between 0 and 1, that is going to be a horizontal stretch, because remember, you have to take the reciprocal. Oh. Horizontal stretch. If your b is greater than 1, that is going to be a horizontal compression. This would be f of x equals, I'm going to put 1 over bx so that you know the difference. This would be bx. If your x is negative, it's reflected over the y. Okay. Then for your vertical transformations, this would be up k. This would be down k. If the a is between 0 and 1, that is going to be a vertical compression. Greater would be a vertical stretch. So this is f of x equals 1 over a root x. This would be a root x. The y is negative. This would be reflects over the x. And it would look like this in your equation. Your hk, it says in a square root, that's your starting point. That's your vertex. Your hk is your starting point. In a cubic, your hk is your point of inflection, which means that's where the graph is going to bend. That's your point of inflection. Okay, so example 1, we're just going to list out the transformations. Left 2, down 4. This should be very easy because we've done it multiple times. On every new function, we do the transformations. This is going to be reflect over x. It's going to be a vertical stretch by 2, and this is going to be right 3. This is going to be a reflect over y. It is going to be horizontally compressed by 1/2 because you have to take the reciprocal, and this is down 6. Okay, we're going to write the equations. We first have to find out what kind of function it is. It's a square root function. Remember, on this, the order matters. So we know we're going to start out with a radical. It's been vertically stretched by 3, so there's a 3 on the outside. Reflected over the y, that means that x is going to be negative, and it's been moved up 6. This one is a cubic function, and we're starting with what we have. So it's been shifted up 3, so that means this is going to change to 5. Left 2, that means it's plus 2, followed by a reflection over the x-axis, so that means the outside is going to change, and that means that this sign also will have to change. So it's going to be negative cube root x minus 1 minus 5. Okay, we're going to list the transformations, find the starting point of the POI, and sketch a graph. So we have a square root function. Let me remind you what the table is. Oops. Your parent function table is 0, 0, 1, 1, 4, 2, and 9, 3. So my transformations is a vertical stretch by 2, and it's going to be moved right 1 and up 3. That's my new origin. So right 1, up 3. That's my new origin. And if it's vertically stretched by 2, that means the y is going to change. So this is still going to be 0, this is 2, this is 4, and this is 6. So this is my new origin. That would be 1, 3. Now I'm going to go right 1 and up 2. I'm going to go right 4, up 4. I'm going to go right 9, which will put me all the way here. And this is my new graph. The domain is from 1 to positive infinity. My range is from 3 to positive infinity. This one, the transformations reflect over x. It's been vertically stretched by 2, and it's been moved up 3. So my new starting point, or my vertex, is going to be 0, 3. My table is going to be my new 0, 0, 1, 1, 4, 2, 9, 3. My new vertex is 0, 3. So my new vertex is right there. It has been reflected over the x, so that means the y changes. And it's been vertically stretched by 2, so that means the y is changed. Multiply by 2. This is 0, negative 2, negative 4, negative 6. So I go right 1, down 2. I go right 4, down 4. I go right 9 and down 6. There is my graph. My domain would be from 0 to positive infinity. My range would be from negative infinity to 3. Transformations, first thing I have to do here is take that negative away from the x, and so it would be negative x minus 2. It has been reflected over y, and it has been moved right 2. My table, 0, 0, 1, 1, 4, 2, 9, 3. My vertex is going to be 2, 0. This is 2, 0. 2, 0. It's reflected over the y, so the x changes. Negative, negative, negative. I go left 1, up 1. I go left 4, up 2. Left 9, and up 3. Here's my graph. The domain is from negative infinity to 2. The range is from 0, positive infinity. This is a cubic function. My transformations is a vertical stretch by 2, right 3. My chart for this one, remember, is negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and 8, 2. my vertex, or I'm sorry, my POI, my point of inflection, is going to be 3, 0. So this is going to be 3, 0. So 3, 0. Now I go left 1, down 1. Oh, wait. I need to stretch that. So my Y will change by 2. -4, -2, 0, 2, and 4. I'm going to go left 1 and down 2. I'm going to go left 8, 2, 3, 4, and down 4. I'm going to go over 1 and up 2. I'm going to go over 8 and up 4. And this is my graph. Okay? Domain, all reals. Range, all real. Okay, on this one, first thing I'm going to have to do is factor out that 1/2 x plus 4 plus 3. My transformations, it's reflected over x. It has been horizontally stretched by 2. It's been moved left 4, down 3. This is square root function, so 0, 0, 1, 1, 4, 2, and 9, 3. My vertex is going to be -4, 3. Negative, the reflection is over x, so the y changes. And it's been horizontally stretched by 2, which means the x will change by 2. 18. So my vertex is -4, 3. I have to go right 2, down 1, right 8, and down 2, right 18, so it's going to be way off the chart. It should look like this. My domain, it starts at -4, goes to infinity. My range is -infinity to 3. First thing I'm going to do here, got to factor out that 2. Okay, this is a cubic function, so transformations here would be horizontally compressed by 1/2, right 2, and down 1. My POI is 2, -1. It's a cubic function. My table is going to be -8, -1, -1, -1, 0, 0, 1, 1, 8, 2. It's been horizontally compressed, which means that's going to change my x. This would be -4, -1/2, 1/2, and 4. Point of inflection is going to be 2, -1. I'm going to go left -4, down 1, left -1/2, down -1. Uh-oh, I messed up. This should be -2. So this is -2. 2, 3, 4. And then over 1/2, up 1, over 4, up 2. Here's my graph, domain, and range. And that's all. Thank you.